Hello, so continue on problems from this weekly contest 328. The third problem, which is count the number of good subarrays. So let's see what this problem is about. So we have an array of numbers and we get an integer k. And we want to return the number of good subarrays of this array. Now, what is the definition of a good subarray? So a subarray is good if there is at least k pairs of indices where one of them is smaller than the other, such that the values are equal. Okay, so we need k pairs of just different positions values that are equal to each other. And so if we take a look, for example, here, k is equal to 10, so we need 10 pairs. So with just 2, we can't make 10 pairs. We can make only 1 pair. With 4, we can make 4 choose 2. I don't know how much is that, but it's less than 10. With 5, we can make 10, right? 5 choose 2. Basically, how many we can make? That's 10. We can make 10 pairs. You can try it. It would be this one, and then this one, and then this one, and then, yeah, you could try to distribute it and count, and it will be equal to 10. So that means basically there is only one subarray, which is the entire array, that gives us k pairs of different of values that are equal but in different positions. And so only one, so we return 1. Okay. Now if you take a look at the second example, is a little bit more interesting. K equal to 2, which means we need at least 2 pairs of indices, right? So if we take a look first here, one, that's not enough. Even if we go till 3, not enough still, because we only have 1 pair with 3 and 3. Here we have 2 pairs, right? With this one, and this one. Okay, so that's a valid subarray here that we have. It's here. Now if we take add this 4, right? Still just this 2, 2, and 3, 3, but it's a different subarray, so we count it. Actually, it's there is an additional pair, which is 4, 4, right? But we still count it because it's bigger or equal to k. It's at least k, and we have at least k. If we take a look at this example, which is basically we move right by 1, then we have 2 2s and 2 4s, so it's valid because we have 2 pairs. So we count it, and then we move right again, and at that point we would have 4 2 times, and then 2 2 times, and so that's 2. And those are the only ones. If you try to move right again, then you lose the 4, so you'd have 1 pair, and that's the idea. Okay, so total is 4 pairs, 4 subarrays that are good, have according to this definition of good. So that's the idea. I hope that was clear. Now how do we solve it? You might think, okay, maybe we can sort of do brute force way where we traverse the array maybe twice or something like that, but that's not going to work because the array the length can be up to 10 to the power of 5. So anything of n squared or more won't work, so we can't do that. Okay, so let's think about how do we solve it then. Okay, so let's see how we can solve this. So the main idea here is that, so we want a good subarray, right? And the good subarray is you have k pairs. Okay, so the first thing you may think about is, well, let's say when we got here for this window, right? We know we have 3 2 times and we have 2 2 times, so we have 2 pairs distinct, right, in different positions. We can expand to this to be like this, and this will still be valid. And even if we had like maybe the array had other elements, let's say it has 6 7 8, we can expand. This one would be a good array, up to this one would be a good array, up to this one would be a good array, right? And so, and even from here to here, if we had 3 here, it would be a good array as well. So just from what you see here, I move either right or I move left, and then we check if the window we are looking at, if it's good or not. And immediately when you do this, which is, you can think of it as expanding your window and then collapsing it, okay, under some conditions. This is exactly what a sliding window does. So your mind should immediately jump to sliding window and think about solving it that way, right? So how do we solve it then with that? So this is the only problem. So how do we do that? So with sliding window, you need to think about a couple of things. You need to think about what data do you need to maintain for your window, because every sliding window is maintaining a window. And then you need to think about when do you expand your window, right? Which basically you would have 2 pointers, right? With a sliding window, you would have I and J. And so you would need to think about when do you move J to the right, which is expand. So this is basically J plus 1. And when do you collapse, which is moving your left pointer, which is when do you do I minus 1, okay? So you need to think about these 3 things. So for our use case, what do we need? Okay, so we need the count of subarrays. How do we know a subarray is good? So that's what we want to know. When is a subarray good? The problem says is if the number of pairs is at least k, which means it's bigger or equal to k. So this tells us immediately that we need our window to maintain the number of pairs so that we can know if our window is good or not. And the window here would be just a subarray. It would be basically just from I to J. Okay, and so here, of course, first J and I stay in the same place, and we need our window to have some data. So our window would have, let's call them maybe window pairs, right? Start out at 0. Now, how do we identify if the number of window pairs, right? Well, how can we tell here that we have for example, in this window, how can we tell that we have a pair? Well, we need the counter. We need to know how many 3s we have, how many 1s, how many 4s, how many 2s, so that we can check the ones that have at least a count of 2, right? And so here, this tells us immediately that we need a counter for our window as well to know how many values we have. Okay, and so for that, we need also a count, which will store sort of, you could use a hash map or you could use a counter in Python, which will store for each number how many occurrences are there. And of course, since we are looking for the overall subarrays, the good subarrays, overall in the entire array, we need to maintain that. So let's call them subarray count or something like that. Good subarrays. Good subarrays starts out as 0. Okay, so now as we move our pointer, what should we do? So we start out both as 0, 0, right? And we check. For 3, we want to add it, right? So we want to add 3 to occurred once. And now, should we move I or J? That's exactly the decision we need to decide whether to expand or collapse. Well, what does make sense is that as long as we haven't reached the number, we haven't reached, the window is not good, we should keep expanding, because if we collapse, we won't. So let's say this window, for example, it's not good, right? Because there is no pair that is 2. If we collapse and move I here, well, that won't improve it. That won't make it good because we are not adding anything, right? Because if it's not good, that means it's missing values. So collapsing won't be useful. So that means if it's not good yet, we want to expand, we want to move J. So what this means is basically expand if window is not good. Window here is subarray. okay? And when do we collapse? Well, let's say we have a valid window like this, okay? And we counted this, and we are done. Like, we counted all the J's. Then the only other thing is to check if this is good, because if it's good, it's something we want to count. We want to count all the good subarrays. And so we collapse only when the window is good and we reach the end of J. Because if we don't, if let's say this window is good and we start collapsing immediately, then the problem is we won't count this overall window, right? And so here, one important thing here is collapse once window is good and G can't move anymore, right? G is equal to N, which we can't move J anymore, right? That's important, because otherwise we'll miss things like this window. And if we had more here, we'll miss this window, we'll miss this window as well, right? So that's important. Let me remove this. Okay, so now that we know when to expand, we know when to collapse, we have our window data, let's just run it, okay? So now we have 3 has value 1. Should we expand or collapse? We still have 0 window pairs. We will increment window pair only if we have at least count of 2. That's what the problem says. And so here we move our J pointer then. So our J pointer becomes here. And now we add that we just found a 1. Okay. And we don't have a window pair yet, because both have count just 1, so we move J again. Now we have 4 occurred once, so we move J again, because still no valid pair yet. 3, now it's interesting. Now we have 2 here, okay? So we have a pair, a valid pair now, so we want to increment this, okay? So basically what this tells us, I'll just write the pseudocode here, is that while J is smaller than N and the number of window pairs is not, when is a window good? It's when the number of window pairs is bigger or equal to K, right? That's exactly what. So here it's only when is bigger, while it's smaller than K, it's not good yet, so we want to keep advancing J. That's what we said earlier. So we want to keep advancing J, but remember, each time we encounter a new value, we want to record it in the count, right? And so here, this means we want to, in count, we want to record the number at J. We want to increment it by 1. What else we want to do? Only if there is a pair, we want to add it to the window pair, like here. So here, we want to add 1 because we just found a pair. And so how do we tell we found a pair? It's just if the count is bigger than 1. So it's the count of the number of J minus 1. Why minus 1? Because let's say we have now, so here we had just 1 3 and we found a 3. Then now the count is 2, but the number of pairs is just 1 because this one gets paired with this one, so just 1. Now what if we had 3 3s and 2 3s and then we just have a new 3, right? So we pair it with this one and then we pair it with this one. So it adds only 2. So the count is 3, but with the new number adds only the count minus 1, right? If you have 3 3s and you have a new 3, we'll pair it with this here, we'll pair it with this here, we'll pair this here, and that's it. The pairs between themselves already existed from the previous iteration, right? And so here we'll add only 3. So we add only the count of the number at position J minus 1, okay? So that's an important point here to understand. Okay, and so this means that, okay, so that's the setup for expanding. So this is the expanding setup. I will touch on when do we collapse here. So when do we collapse? For collapse, we will maintain I in range of N here for collapsing, but we'll see what we'll do there in a minute. when we have the case here. Okay, so we keep moving our J pointer here. And now, do we have 2 pairs yet? No, it's still 1, so we keep going. That's from this here, right? So we keep going because it's not good yet. And now we have a 2 with occurrence 1. So we move our J again, and now we have 2 occurrences of 2. So we increment our 2, and now we have a 4. So actually we stop here, and now we have how many? It's 2 here, right? So this window pairs, this needs to be plus, by the way. Plus count of the number minus 1, that would be 2. Plus 2 minus 1, which is plus 1. And so now we have 2. So now we have it bigger or equal to k. Okay? And so now, if once we exit here, we want to check whether it's because we reached J, but still we don't have enough window pairs, or because we have enough window pairs. So if we have enough window pairs, which means basically, so this means subarray is good. What should we do? Well, as I said earlier, we want to count this subarray because it's good, but also this subarray is good because since this one is good, adding more will only, the thing says bigger or equal to k, will only make it better or make it, it will stay the same. And if we had more numbers like 7 here and 8, we will still want to count all of these. Okay, so how many we need to count then? Well, we need to count all of these because each of them create the numbers here. How many of them? Because all of them, each of them creates a new subarray. And what is this here? What is this? So this is J, position J, and this is N. So what is the number of this? This is just N minus J plus 1. Okay, so this means that the overall window good subarrays that we initialize, of course, to 0, here we need to increment it by N, the length of the array, minus J plus 1, right? Because as I said here, we can create this one, we can create this one ending at 4. If we had other numbers like 7, we need to include the one ending at it, and then we'll need to include the number ending at 8. This is because if you have a good subarray, if you expand more, you would only get a good subarray, right? Okay, so I hope that was clear. And so our G here, so we'll count that, but our J will stay the same there in that position. But what if we exited here, but the window pair was bigger or equal to K? It was smaller than K. That means J was equal to N. And the window pairs was smaller than K. Well, in this case, so that means we reached it here, but we didn't have enough pairs. Let's say maybe K was equal to 3, right? Then that means we reached it here and we didn't, maybe K equal to 4 actually, for example. So if we reach here, we still have only 3 pairs, right? And so if we collapse, we will only get either the same number of pairs or less. So if we weren't able to achieve it, then we won't achieve it, and so we can just break right here. Okay. So that's the idea there. Now, once let's go back to the example where it's K equal to 2. Now we have a valid good window. Now we can start collapsing to see if we collapse, if we will find another good subarray. And so we move our I pointer here now. Now, what should we do if we move our I pointer? That means we need to remove this from both our count and from the window pairs. So removing it from our count is easy, which would be just number at I minus 1, because the count decreased by 1 for this window. But for the pairing, let's say let's say for example two threes, and we just collapsed I, which was at a position that has 3, so we want to remove this one. What should we remove from the window pair? Well, with 3 we had this one, right? We had these 2 pairs attached. Why 2 pairs? 2 pairs is just the numbers without this one, so it's just the numbers minus 1, but we already did minus 1 here, so it's just window pairs now minus this value here. If we hadn't done minus 1, we need to do minus 1 because the pairs are just the other numbers, right? And so this would be minus the count of nums of I. I hope that was clear. Let's take it again. Let's say we had 3 threes, right? We are removing this number. So what pairs should we remove? We should remove the pair that was with this one, the pair that was with this one, and the pair that was with this one. It's just the other numbers. So it's just minus 1, right? And minus 1, we already did it here. So no need to do it again, right? Okay, so that would be for the collapsing piece, right? So we move, so let's apply it here. So we move our I, which means our number of threes decrements here by 1, and the number of pairs decrement by 1 as well, right? Because we just remove the 3 pair here, no longer works. Okay, so now we move our I pointer, we move our J pointer now. Okay, so we move our J pointer here because the window pair is just 1, it's smaller than K, so we move J, and now we have 2 here. And now our window pair increases by 1 because we just have a new one. And now we are bigger or equal to K, which means we need to add to our overall, sorry, here I forgot to add that we had 1 good subarray. We had 2 good subarrays, right? Okay, and now with this we have 1 other good subarray, right? Because it's just 1, there is nothing else here, so n minus j plus 1 will just give us 1. And so here we are going to add a third. Okay, and so we collapse our again. Now we are done, we collapse this again, so I here, so we decrement by 1, this one here, so it becomes 0. Now 0 minus window pairs minus 0, it just stays the same, right? This wasn't a pair initially. And now when we go back, j is equal to n, but the window pairs is still bigger or equal to k. That means we need to count this subarray because it's a good subarray. And so we count it again, and we have 4. And now we move again, and we collapse, and now we have less 4, so our 4 is just 1. And now that means we subtract that 1 from here. Now this is 1. And now we no longer have a good subarray, but we'll keep collapsing, and we won't have a good subarray until we reach here. We are done. We can't, there is no longer a good subarray. Of course, we'll need to decrement this, and this would become 0. This would become 0. You get the idea. But overall, the result would be 4, and that's exactly the solution we have in the problem. And that's roughly the idea. So, and this is the code that we did in tandem with the simulation. So, sliding window technique, we keep track of the window pairs, the number of pairs, of the count of the occurrence of each one, and we decide when to expand and when to collapse. We expand as long as the subarray is not good. We collapse when it's good, and then each time we count, and we do not forget to count for G to expand all the way to the end. Yeah, and this optimization here also with break. When the array is not good and J reaches the end, collapsing will only make it worse, and so we just exit. Yeah, so that's pretty much it for this explanation. Now let's write it and make sure it passes. Okay, so let's write the code we saw in the overview here. So we just need to define a couple of variables first. So the first one would be n for the length of the array. And then we need our window pairs, right? The data for our window. So So let's call this window data, right? And then we need the result that we are going to return, which is the subarray or good subarrays, right? This would be just the count, and then we need the count for the occurrences. And for Python, we can just use counter. Feel free to use a map. And then we need the positions themselves, so J. And that should be it. Now we will do a for loop for I for collapsing it. But for the expand, we'll use a while loop. So while J is smaller than N, and the window pairs are not yet making the window good, which means they are smaller than K. So basically, this is because the problem says good means window of pairs are bigger or equal to K, okay? And so here, when we have a new number, we want to add it to our window, and window pair would have a new one if the number -1 is bigger than 0, right? So if we have just 1, this would be 0, we won't add anything. If we had 1 already and this is a new pair, this is a new value that is the same, then we'd have 2, and this would be 1 minus 1, give us a pair, because 2 values give us a pair, so it makes sense. And so here we want to increment J, of course, because we just used this number. And now we exit this while loop. Either this was because it's bigger or equal to K, or we reached N and we didn't find enough pairs. So either we find enough pairs or not. And so here we will check if we found enough pairs, right? This means that current window is good, is a good subarray. So we need to count it, and all of those to its right, and all subarrays from values to the right of J, right? Because if we don't count them here, we won't count them, because after that we will only collapse I, right? And so to do that, we want to say good subarrays is plus the entire thing after J, which is N minus J plus 1. Now otherwise, this means basically window pairs are smaller than K, but we still exited this while loop. This means that J is equal to N, okay? This means that we reach the end, but we don't have a good subarray. So from here, we can only collapse I. But collapse I means reducing the values in the window. So if we don't have enough now, we won't have enough ever. And so we can just exit. And now here we want to collapse. So this would be collapse window, which means from I, which means moving I to the right. And this portion here is expand window. Okay. And so here we subtract 1 from J. It's from I, sorry, because we are collapsing at I, so we are moving I to the right. That's what this would do, because it would go from I to I plus 1. And now, since we removed this number, we need to remove it from the pairs as well. And how do we do that? It's just minus the count of that number, right? I already gave the explanation in the overview. You can go back to understand why we do this. And then at the end, now we are done, and we can just return the overall number of good subarrays. Okay, so yeah, pretty much just sliding window technique here. The tricky part is knowing your window data and the when to expand, when to collapse. Okay, looks good. Let's submit. And that passes test cases, right? Yeah, so that's pretty much it for this problem. It's a good application of sliding window technique. Yeah, please like and subscribe, and see you on the next one. Bye.